Welcome to this video. We'll be taking you through the OCR GCSE Computing June 2015 exam. So I wasn't planning on covering this actual paper because exam boards tend to withhold the previous year's paper until sort of about August, so basically after the year 10 mocks. But I managed to find this paper very easily, so if I could find it, so could anyone else wanting to know the answers, and it helps to maybe go through it if you're revising for the exam this summer. So that's as I record this video for June 2016, which is going to be on the 8th of June, so that's after the half-term break in the exams, so you have a bit of extra time. So yeah, this is the date if you don't know it already. And also another reason why I wanted to do this paper was based on the grade boundaries. If we zoom out there, so I've actually gone through and tried to, basically recorded all the grade boundaries I could find for this course. I think the first couple of years, maybe even January 2012, it wasn't a public course, or maybe these were pilots or samples, I'm not totally sure. You can see the first 2 years for 2011 are both the same, so maybe these are provisional ones. But regardless, it does fluctuate a bit. It was kind of steady for a few years, and then the last 2 exams in 2014 and 2015, there's been a lot more fluctuation. So in the very first video in the series I have covering this course, I showed you some grade boundaries, and I've no idea where I got them from. I honestly can't remember, but I think they were almost completely wrong. So these are the ones you want to be relying on. But even so, I wouldn't place too much emphasis on them because it's a bit of a lottery. You can't say definitively, okay, I want to get an A so I can drop 30 marks. It doesn't work that way. You've got to be very careful applying that kind of thinking. So as you can see, it's not a very statistically sound way of calculating it, but the June 2015 total of all the marks, of all the boundaries, was the lowest, and so it's another reason for covering it, and all of these are out of 80, by the way. Alright, if we actually start by going through the paper, it might help. So just a few things to note maybe is that it's an hour and a half, so plenty of time. That could be a good or bad thing depending on how you see it. Also, you are allowed calculators. I always get loads of emails asking about calculators, and I always have to reassure people that you're allowed them, and it's out of 80, as I say. Alright, if we begin with the first question, so it's asking us to state a input device, an output device, and a storage device built into a smartphone. And so I'm just going to label it because it's slightly more maybe helpful. So if I just maybe put down some suggestions. So the first one I thought of was maybe a input, if I can spell fingerprint, input device. First of all, a device is just kind of either a mechanical or electronic sort of object. So a button does count as a device, but also the latest iPhones have a fingerprint scanner. You've maybe got to be a little bit careful. It doesn't necessarily to refer to this diagram, which is clearly of sort of an iPhone, but some of the latest phones have fingerprint scanners. You've got to be a little bit careful to avoid using the brand names. So Apple call this Touch ID. Don't ever refer to it like that. So an example of another situation where you've got to be careful about brand names is if you are asked to maybe talk about a image processor or an image editor and you call it Photoshop or Microsoft Word. If you're talking about a text editor, you've got to be a little bit careful in that regard. Another example of an input device would be the camera. There's a front-facing camera here. That's also an input device. You have a speaker here, which is an output device. Also another output device you've got to be, again, something to be careful with, is that the touch screen here is both an input device and an output device. So the touch element to it is what makes it an input device because it's basically a button, but the screen is output, quite obviously. So you've got to be a little bit careful maybe. This is maybe one device, I can't think of another that would count as both. So in terms of storage devices, there'll be some kind of memory, flash memory probably. Also there'll be a SIM card here somewhere. The SIM card sort of stores details allowing you to, allowing the network to authorise you so you can send calls and texts and so on. So if I just write one down, so these are maybe the safest 3 options. You've got to be thinking, it would be very easy just to see this first question. It's a nice relaxing question. You might be nervous, you might be anxious to get on with the paper, and you might just not really read a question. One key bit maybe is built in. So it does say built into the smartphone. So something like a headphone, you might have a headphone jack. That doesn't count as a built-in device. It's a speaker, headphones, but they're not built into the phone, so you've got to be very careful. Also, you might just see secondary storage and think, okay, hard disk, that's the main secondary storage we use, but that would definitely not be appropriate for a smartphone, because first of all, for very power hungry secondary storage devices, hard disks are very power hungry, they're mechanical and they're not very durable. If you dropped your phone, if your phone is lucky enough to survive, the hard disk wouldn't, and more reasons I can't think of. So you've got to really be very aware of what the question asks you in this context, although the actual content of the question is relatively easy. The next question is asking us about files. And the first part of this question, which is really just asking us to match up some file formats, is 4 marks. So the first 7 marks of this paper are really straightforward. So this paper is definitely a bit of a mixed bag. So really this one is just asking us to take some context and suggest the most suitable type of file. So there's not really much revision you can do for this. Actually, I might as well show you. I copied in the table that was in my, I think the internet topic, without minus the GIF that isn't the one listed, but you're welcome to pause it and read these if you want to revise that a little bit. You should immediately say that JPEG is for images, MP3 is for audio, MPEG is for video, and PDF is for text files. And so the first content, an image showing a map of a school, that's going to be the only image option, which is JPEG. The next one is a text document, and the only option is going to be a PDF. A high resolution picture of all the staff and pupils, so again the only image, that's going to be a JPEG, and finally the short video clip is going to be the MPEG. So again, those 4 marks should really be pretty standard for you. The next part is asking us to talk about lossy compression and explain why lossy compression is suitable for a video clip but not suitable for a text document. So the first thing I would do when looking at this question for the first time is look straight to where the marks are. There's only 3 marks for this question. There's a lot of space here, way more than you need. And so if you can, a good skill you'll develop as you sit more and more exams is trying to work out what you're going to get for your marks, and you develop this skill by practicing papers and then looking at the mark scheme. And so it'd be very easy to see all this space and just write loads of things that aren't going to get you marks. You might write about lossless compression, which is the other type of compression. You might be defining lossy compression, and probably all of this is going to be unnecessary. It's not really relevant to the question. So as I say, there are 2 types of compression, lossy and lossless. The purpose of compression is to reduce the file size, but you want to retain the underlying information. So lossy compression works by selectively deleting part of the data in order to, as you can imagine, reduce the file size, whereas lossless compression is slightly more subtle. It works by making the storage more efficient in order to reduce the file size. So why would it be unsuitable for a text document and suitable for a video clip? Well, if you started deleting certain bits, not all of it, of a video clip, the quality would start to reduce. And ultimately we can deal with that. That's not going to be too integral. It's going to annoy us potentially, but it's not going to ruin the video clip per se. Whereas if you started deleting bits of a text document, it's immediately going to become unreadable and important information is going to be lost. So if we put this into words, alright, so what I've written is using a lossy algorithm on the video would reduce its quality but not make it unwatchable, whereas selectively deleting parts of a text file would make it unreadable. So I really haven't written much, and I know it's probably barely readable anyway, but you know, I'm using a graphics tablet, so it makes everything longer, and I've barely used up less than half of the space. So don't get put off, or don't write to the space always. There's going to be times you're going to write more than the space, which is fine, but it's just a guide. So I've just quickly looked at the mark scheme to make sure my suspicions were correct. And if we just look at the 3 points, a mark each, the first one is about reducing the quality. The second one is about making it unwatchable. And the third part is about, whereas deleting bits of a text file would make it unreadable, that highlighter has not worked. Okay, fine. Moving on. So the third question begins with showing us a flow diagram, and it's a representation of a computer program that calculates the correct dose in grams of a type of medicine. The very first question, or the very first part referring to this isn't, it is. Okay, so it's talking about variables used in a flow diagram. So it's just to state the data type, 3 marks. You get a mark for each. So the data types you need to know are string, boolean, character, integer, float, and I think that's it. I may have forgotten one, but those are the basic ones you need to know. There are other data types. You should be aware of that different programming languages have their own data types. These are the simple ones. for you to know, I think. So the very first one is gender, and so we could guess straight away the gender is probably going to be, well, it's going to be male or female, so it's probably going to be a string. A string is just a sequence of characters. A character is the single, and usually we use quote marks for string. Could be single quotes as well, and a character might be this. It's represented in different ways. So the gender, if we can look for any clues just to be sure, yep, well, gender equals female here, so this is the format they're using. So if this is a string, and so the variable actually will have that type of string. The variable dose is, well, we can see we have some calculations with dose, and so this asterisk is being multiplication, and so here in this just variable, as we're going to have to look at in a second, we're multiplying age, another variable, by 0.1, and so this is going to be a float or a real. I'm going to call it a float, so it's not going to be an integer. So an integer is a whole number, and so this isn't going to be an integer because we're multiplying it by a fraction. So it's going to be a fraction anyway, and the fraction data type is float or real, but I'm going to call it float. And is pregnant. This is again, we look for clues in the flowchart. So is pregnant here is written here, and it's written equaling true, and so this is going to be either a true or false value, and those are Boolean value. So a Boolean value is either true or false, and we tend to write it in capitals, either true or false. So this is going to be Boolean, and that's all we need to do. Easy 3 marks, hopefully. The next part is asking us to use the flow diagram to calculate the correct dose of medicine for a male aged 30. So this is a key bit of information. So really the fact that it's a male and the fact that they're aged 30. So the very top, if I switch to another colour, I'm going to do it up here just because it makes my life a bit easier, makes it slightly less awkward to have to switch. So the input of age for the male is 30, and well, the gender is male. We can do it in quotes if we want. So by the way, if it asked us instead to say the data type of age, well, it would be an integer, because you're not going to be 30 and a half. That's not how ages work. You're either going to be 30 or 31 or 32. So that's would be an integer variable. Anyway, so what we have to do basically is trace through until we get our final result at the end. By the way, a parallelogram is not really one of the standard flowchart symbols, but this means input or output. So first of all, we need to say, and by the way, this is asking us to show our working, and it's a bit of a strange way to phrase it, but really they just want you to show your logical thinking as you go through it. So in this case, when you're not totally sure what's going on, maybe, I haven't come across a question like this before, you just have to be really careful and write everything out. Don't just skip bits, don't just write 0.5 times whatever it's going to be. Make sure you write everything out. So I'm going to write this write it out up here. So the first bit is whether the age is less than 20. So 30 is less than 20. That's false. You have to evaluate so it's false or no. So this decision is evaluating to false, which is no, and so the dose equals 2. So let's write this out. So the first bit I've written is that the age is 30, and so the age being less than 20, well, 30 is not less than 20, so that evaluates to false, and therefore this symbol I use quite a lot I use it personally quite a lot when doing sort of logical maths or trying to show a proof. This just means therefore. So age less than 20 equals false, therefore the dose is going to be equal to 2 at the time being. You don't have to use a symbol, but it's quite good when showing your train of thought. So this means therefore. You might also see this sign, which is implies. So the next stage is to then go to the next decision, and so that's whether the gender is equal to female. Well, it's not. This evaluates to false because our gender is male, and so the dose is now going to be the same as the previous dose, which was 2 multiplied by 0.5. This could be a mistake someone could come across. They might not know this is multiplication. They might think it's this symbol, which is actually about exponentation, so raising to an exponent. So if this was dose, this symbol 0.5, this would be basically finding the square root of the dose, because anything raised to a fraction refers to a root. So a half is a square root, a cube is a cube root, but this is not what this is. We're simply multiplying it. Therefore dose is going to be dose times 0.5, which is going to be equal to 2 times 0.5, which is going to be equal to 1. And so that is our final answer. We have the n symbol. So our final answer for this is 1. I'm just going to copy this into the actual bit. So one thing you might slip up on here is just the fact that when it's written like this, dose equals dose multiplied by 0.5, we're using the dose you've already used. So we're just using the variable currently stored as dose and we're basically replacing it by this calculated value. That's for maybe a bit you could trip up on. The next one is slightly harder, same kind of idea. This time we're dealing with a pregnant female aged 19. So we have 3 inputs here. The first 2 are going to be used again. So the age is 19 of the gender is female. The age equals 19, so age being less than 20 is now evaluating to true, or yes. Therefore the dose is going to be 19 times 0.1. You could obviously use a calculator in this situation, but multiplying by 0.1 is the same as multiplying by a tenth or dividing by 10, so this is just 1.9, so the dose is 1.9 at this stage. We have to move on to now evaluating the fact that the gender equals female. Well, it does, because the gender is female, so female equals female is true, yes. Also we have to input a new one, so is pregnant, well this is true. So first of all we need to say gender equals female is true. We have an AND operator here, and so for an AND operator to evaluate to truth, both sides need to be true. And so is pregnant equals true? Yep, that is true, we've just inputted it here. And the dose is greater than 1.5, yeah, 1.9 is greater than 1.5, so that's also true. And so we can write in the next line. Therefore the dose is 1.5. So this was 4 marks, the question above was 3 marks, and this, the Daystart one was 3 marks too, so a total of 10 marks just for interpreting a flow diagram. You just got to be careful in this situation to make sure you actually follow their instructions of writing out your working, because that's what's going to get you the marks. So the next one is asking about security. So security on a computer can be provided directly by the operating system or by using utility programs. And these include antivirus, file transfer, firewall and system cleanup. So state which 2 of these utilities can be used for security. Okay, well immediately, hopefully you'll see that this is going to be antivirus and firewall. So quickly just to go over, antivirus software is a program that detects and eliminates malicious software, so the actual virus. File transfer, this program basically just allows files to move around, copied and then deleted by the user. Firewall is a program really for networks that controls and filters incoming and outgoing traffic, and system cleanup can be used to speed up the performance of a system by deleting old and not used files. But these are the only 2 that have anything to do with security. I think you could probably tell, or you could have an educated guess. Antivirus you should get, but firewall, the name kind of suggests security even if you didn't know it, but these are worth learning because well, just in general. Part B of this question is asking us to identify and describe 2 methods by which the operating system can provide additional security directly. So it's a 4-mark question. 2 marks go to each reason, and 1 mark would go to for each identification, so just stating basically what feature or what method, and 1 mark would go to the description of how this is an additional security measure. So the 2 key words here which would maybe change the meaning of what you'd write. So additional is really just saying non-utility, so obviously you could write about antivirus and firewall, you'd be wrong because we're talking about the operating system now, but also directly. So I guess firstly I should say that the operating system, if you don't know, is this essential bit of software in your on your computer that links the hardware and other pieces of software together, so like the applications, the utility software like these 4, and also manages the computer. So part of its purpose or function is to manage the hardware, manage the programs being run on it, and to manage the security. So the security is this key function of the operating system. So I think directly matters because part of the nature of the operating system is to act with additional security anyway, because I might have showed you a diagram similar to this, I honestly can't remember, it's quite a common diagram, but really the operating system is providing this layer between the hardware, so this is the OS, and any applications. And this layer of abstraction, as it's called in computer science, this sort of additional abstraction, I guess by definition is going to form more security. And also, in the video I talked about a layer a bit of code that forms part, a very important bit of code that forms part of the operating system, really a core bit of code called the kernel, and I think it confused a lot of people. I didn't mean it to, obviously, and maybe it was unnecessary to talk about, but really the kernel is what manages the system resources. So all applications running have to go through the kernel in order to access the hardware, and any incoming connections like networks have to go through the kernel bit of code of the operating system to access the hardware. So I guess by definition this is going to provide additional security, but I think directly means methods that are obvious to the user, because this isn't, you don't really think about this layer of abstraction means we don't think about what the kernel is doing. We think about things like passcodes and passwords and user access levels. So this is what this means. These are the two methods we need to talk about. So the first one, I think, is maybe the obvious one. And for this question, you really got to think about what, when you're using your computer. So an example of an operating system would be like Windows or iOS. You will be thinking about what additional security it provides to you, the user. So one of them is going to be the use of passwords. And so in some cases the operating system may even encrypt your password. So recently in the news has been, you probably would have read about Apple and the FBI have gone to court because Apple were trying to prevent the FBI from accessing a terrorist iPhone. The FBI wanted Apple to basically decrypt the iPhone. Encryption is just making data unreadable to people who aren't meant to see it. And in the end, an Israeli, I think, security firm managed to decrypt it for the FBI, or access by brute force maybe. But one of the functions may be to provide encryption for passwords and other things for the user. But the maybe simple answer would be the password prevents people from accessing things which they're not meant to. Okay, so I've written these only allow access to the system if you are authorized. You have to log in order to be able to see any of the files in the first place, and that's a function, a direct method by which the operating system provides this extra security. I've had a quick look at the mark scheme to make sure I'm going along the right lines, and actually encryption is one of the points, so I'm slightly surprised because encryption isn't actually on your course, but passwords is as well. And also the second point I was going to make was something called user account control. So I've called it user account control. The general generic term is user access control, as I called it earlier, and so this is very Windows-based responsible, only we knew how to phrase it in the Windows way. So this basically just prevents unauthorized changes to the system either by a user or by an application until permission is given by the administrator. So I'm sure you've all seen this if you've used Windows, where the window pops up asking you to put in your password. You basically just give permission for an application to do something, or a user to access a certain file maybe, or to move a file. So really this question isn't, it's nothing really you need to learn. I think really this is just interpreting what the question is asking of you and using your common sense a bit, or at least your knowledge of computers. There's nothing really you can read in a textbook about this, because for security, when you're learning about security in terms of operating systems, you're learning more about this kind of what's called, well, okay, without going into it, it's sort of a virtual machine aspect of it, rather than these actual features of the operating system. So this is the first example of many questions where really you almost need to think there and then in the exam. You can't really be preparing for questions like this because they're application questions which are asking about specification but go slightly beyond it maybe. So I wouldn't maybe recommend doing this in the exam. I've just done the full stop and just the point, just to identify this 1 point for identification and for 1 point for description, 1 mark I should say for description. So hopefully you can see how you've got the marks in for this question. Question 5 says, Graham is a freelance programmer. He's written a program for a client and gives the client both a high-level code and the machine code of the program. Describe what's meant by high-level code and machine code, and again it's 4 marks. So it will be 2 marks max for both points. So high-level code, we have, and I talked about this in the video, we have this spectrum of programming languages. At the top, high-level languages, so this is high-level, and these include things like Python, Java, and so on, basically the languages you would use in most contexts. You also have low-level languages, and these, it's not really asking about these as a category, but you have assembly code here, and you also have machine code. So again, this comes back to a term I was using called abstraction. If you think of this as the hardware, low-level languages, so machine code is just zeros, ones, this is the closest you're going to get to the hardware. Assembly code is really just replacing this with mnemonics like add, and then we go up here and we have proper statements like if and print. So high-level languages are much more designed for programmers, designed for humans. It uses words like print and like if, which belong to our natural language, English. It's also, so a feature of high-level code is it's so it's portable, and this means basically you could run some Java code on most computers. You need a compiler or an interpreter to translate it to machine code. So for a computer to execute anything, it has to be in machine code form. So whatever we're writing in, we have to translate to machine code. So the translation process from assembly to machine uses something called an assembler. I'm pretty sure that's on your course too. A type of translator called an assembler, and the rest would be an interpreter or a compiler. So the 2 points I want to say about this is that it's designed for humans. So I'm going to do 2 points from high level and then machine code to try and get 4 marks in total. So the second feature, as I say, it needs to be translated before it gets executed. So it needs to be translated by either a compiler or an interpreter before it can be executed. Execution just means following the instructions, so it's the CPU actually processing this and following the instructions written in these human-like statements. So this is, as I say, machine code is zeros and ones, which is binary. So they're binary instructions. And a key point to do with this is, so I said that high-level code is portable. I mean, it can be executed on many computers, although you need a translator. Whereas machine code is non-portable. And this is because machine code is written specifically for a processor's instruction set. So the instruction set of a processor is really, it's just a table, or I think of it as a table with just the binary equivalent. So this could be sub for to subtract, the equivalent of an instruction and the binary form. And this varies process to process. So different processors have different instruction sets. So some machine code being executed on one computer would do something completely different on another computer because they're different process instruction sets. So really, it's non-portable. This is written specifically for a processor. So yeah, it's specific to one processor, so it's not portable. And if you just bring up the mark scheme to see what other points are here, so there's quite a few points. I mean, this would be quite a good revision. Often mark schemes are quite good revision because in some ways they're perfect notes because you know exactly what the exam would want you to know. So as I say, it's written for programmers. Machine independent, so as I say, this is portable to different systems, need to be translated, yep. Problem based, okay. And for machine code, so it's for the CPU to execute, yeah, the processor. It's in binary and it's specific to a particular type of computer, or more specifically a specific type of CPU, and it doesn't need to be translated. So the machine code can just be executed by the processor directly. Next part is just a 1 marker, so it's going to be a simple answer. So why does Graham need a compiler? Well, he's writing high level code, as it says, and he needs to translate it to low level code, or machine code specifically. So as I say, the other type of translator is the interpreter, whereas the compiler compiles everything in one go and then produces this executable file which can be executed, whereas the interpreter does it line by line. So you need a compiler to translate high level code to machine code. Apologies for the handwriting. Part B of this question is a 6 marker, and we're sticking with Graham, and now he's hired a small team of programmers to work with him on larger projects, and we're asked to describe the standards that Graham and his team should apply for the code they produce, justifying why these standards are needed. And it says the quality of written communication will be assessed in your answer. I'm sure you know what this means. Most GCSE exams seem to have this component, and so really this means your spelling, punctuation, grammar, and so on will be, I mean, it's not really much, it's not so much that you'll gain marks for having good spelling, it's more that you can be deducted marks for not having good spelling, especially when it comes to technical terms. Although this question isn't super technical, this is the question that I knew was in this paper before I even looked at it, because I got so many emails after the exam. The main focus of those emails seemed to be about this question. A lot of people seemed to get confused by it. A lot of people were worried that they didn't write enough, or they didn't write about the right right thing. And I think this comes maybe from a fact that, first of all, I didn't cover this that well in the video. It was the very first topic, and I didn't cover it that well, I don't think. I can't totally remember what I talked about, but I don't think I talked about too much about it. And there's not a massive amount to talk about, actually. I think the textbook, from what I've heard, the textbook seems to... I haven't got it. The textbook seems to talk about different types of standards, like de facto, proprietary. I get asked quite a lot, my teachers taught me this, is it in the course, is this going to be in the exam, and so on. And a lot of the time I can't say for certain. All I can go on is the specification, which is what I use to make the videos. And the thing I suggest to people is to go back and look at past papers, because there's been quite a few OCR papers, as we've looked at at the very start of the video, and if it has come up, or if you do need to know, then it probably would have come up by now. So this question, in fact, this is a 6 marker, and it's got nothing to do with de facto or proprietary. It's more the actual standards, hence describe the standards that Graham and his team should apply to the code they produce. There's more about standards within coding. So by standards we mean agreed conventions, and in this case it's agreed conventions between a team of programmers, and it's talking about what things are they going to be using in their code in order to remain consistent, in order to have these conventions. So if you just come up with some ideas, maybe. I always tend to, for a long mark question, so even for a 6 marker, it's not exactly the longest you're ever going to get in any exam, but for a long mark question, if we just come up with maybe some ideas. So this includes things like descriptive variable names. So if all of the programmers use descriptive variable names, so this is saying, so like username equals whatever, instead of like var1, because immediately this is much clearer to a reader what this variable is containing, whereas var1, who knows, that could be anything. A second standard might be use of subroutines. We might have heard it as subprograms, or variables, not variables, functions or procedures, or maybe methods. So these are the kind of principle of a subprogram or subroutine is you have this problem and you can break it up into an individual subroutine, and each subroutine will kind of tackle a individual part of the program. And this is especially useful when you're working as a team, because if you can split a problem up, it's called decomposition, splitting a problem up into individual parts. Each person can tackle each part of the problem, and if you're going to be using subroutines, so not everyone would use subroutines, it's very good programming practice to use them for reasons I don't really want to go into, but it's much better to use local variables and then pass data with parameters than use global variables. So another really obvious standard, which is so obvious that it's taken me a bit of a while to think of it, is the same programming language. You need to, well, you're probably going to want to have a consistent programming language. People in the team might know a certain language themselves. If you set someone a task, they might be comfortable in Python, whereas everyone else is working in Java. So you need to agree upon a set standard programming language. A slightly more subtle one is use of comments. I'm sure you've been encouraged to use comments by your teachers in your code, and it seems a bit pointless at the time, and maybe it's part of your controlled assessment too, I don't really know. Well, comments make it, again, similar to descriptive variable names. They make it a lot easier to see what is going on. If you're explaining your code, especially when someone's got to go and fix part of your code, if you're stuck on something, a comment is going to make it a lot easier. And especially if you're working on this project as a team, and then you leave, you work somewhere else, then if you have comments on your code, it makes it easier for the next person to understand what's going on. A final standard, if I can think of for now, is using indents. And so indents, I'm trying to draw this. We have code like this. These are the indents with gaps at the start of each line. And so some languages like Python, you might have learned, have this indent as part of the syntax. White space is very important in Python. But other languages, you don't have to put indents. But lots of people say it's preferable, it's good programming practice too, because it makes the source code a lot easier to understand. It's like if you have loads of text in one paragraph, it's a lot harder to understand than text that's kind of broken up into several paragraphs. It's kind of the same with indents. It makes it a lot easier, especially when you have a scope developing, and you can see the scope a lot easier with indents. So these are more standards than you need to talk about. I'd maybe only talk about 3 of these. I mean, it's not exactly a ton, and I wouldn't spend this long on planning either. If we just, we have to justify it too. So these standards, and especially I guess if everyone's using subroutines or if everyone's using descriptive variable names, it adds consistency. Also compatibility, especially when it comes down to the programming language, you want it all to be able to run together. Also, as I kind of said, it makes it easier with indents and descriptive variable names especially, and comments actually as well, to understand and read the code. So I'm going to write this up, I won't show you me doing it. So what I do in the actual exam, obviously this is a bit of an artificial situation, I was just trying to show you a bit of my thinking and a bit of more ideas. So what I'd probably do, just as a quick plan, it's a 6-mark question, and I tend to like to do a minute a mark, and I'd probably spend a minute planning, and I'd probably just write indents, comments, just off the page or wherever really, just as a plan, and maybe some justifications. I often would annotate the actual questions, so I'd go, okay, let's do programming language and so on, to just plan it, because if your quality of written communication is going to be assessed, you don't want it to be really incoherent. So if you can plan it slightly, I guess like you would in an English exam to an extent. So let me just show you first the specification. I was going to bring this up earlier but I forgot. So the actual point for the standards is this one here, and it says you need to be able to explain the need for adherence to suitable professional standards in the development, use and maintenance of computer systems. There's nothing about the actual type of standard used, it's more what we're talking about basically. So the question is perfectly legitimate in terms of what the specification says. So this is the mark scheme. I know I've seen it before, so I roughly know I'm along the right lines, but this is the bit I want to show you. So you don't really get marks, it's not like you get a mark for each point, it's more a slightly more holistic approach. So to get the top band, which is what we're going to be aiming for, you need to talk about a number of them. So I'd say 3 maybe would be good. I mean, a couple of points for justification, but really you need your technical terms to be nailed on. So that's things like subprograms, subroutines, whatever I'm going to end up calling it, and a few errors, which hopefully I can avoid. Okay, I've just typed up what my answer might be in the exam, basically just using the ideas that I did when I was, quote, planning, although like I say, I wouldn't plan in that much detail. So yeah, basically just keep it simple in these long mark answers. We've got another one to do later, so I don't want to talk about this too much. So you can pause it, read if you want to. And just a point, it's always important to check, especially when it's a standard written communication answer. I copied this in, then read it again, and I missed off a D here, so that might lose me a mark in the exam. Yeah, not really much else to talk about. Sometimes you get marks for definitions, in this case you don't, so I've just written what a standard is, although it's not really a very complicated definition, and you just got to stick to what the question says. So it might be saying describe what a standard is, and then you'd write more about the definition, but it doesn't, so don't worry about it too much. It's not a proper essay, you don't have to include or anything, it's only 6 marks. And anyway, this question, so I wish I'd talked more about it in the video on the standards, but really none of these responses are particularly technical or difficult. I would like to think most people would have learned about these anyway, or they're not too complicated. Anyway, let's move on to the next question, which is about databases. So hairdresser uses a relational database to keep records of his clients and their appointments. So there are 2 bits of data we could maybe talk about here. And the hairdresser uses off-the-shelf data handling software to manage the database. Part A is asking us to state what is meant by off-the-shelf software. Only 1 mark, so we need to make 1 point. And off-the-shelf software is really programs you can buy. That wouldn't get you a mark, but these are programs that you can buy that are aimed at lots of users. And this contrasts with custom written software, which is designed specifically for a user or a client. Whereas off-the-shelf software is something like Microsoft Word, aimed at lots of different users. There's not a feature in particular that's useful to just one person, it's sort of a general bit of software. So software written for lots of users as opposed to specific users. Part B of this question says, describe how data handling software, or the database management software, whatever you want to call it, can be used to set the structure of the database. The structure is quite a key word here, before any data is added. This is really important too. So the kind of idea here is, if you're making a database, or the structure of a database, so we have our tables, that's how we visualize relational databases as tables. One of them might be a key field this one might be a key field, but regardless, before any data is added, it just looks like this. We just have our columns or attributes, and we have no rows at the moment. And when we add data, we add our rows in, and it specifically says before any data is added. So we don't talk about rows in this at this moment in time. So just a couple of ideas of a structure. Really, this is talking about, maybe mention a little bit of the tables. For columns, as I say, things like the relationships between the tables. This is a relational database. These are modelled using keys. So the primary key in one table is a foreign key in another table if they have this relationship. So I just paused to get this image because I wanted to show you this, just because, as I said, columns or attributes reminded me that actually this might be quite useful to show you, because when I first learned about databases, one thing that really confused me was I was trying to learn about it from different sources, so a website, videos on YouTube, and each source seemed to seemed to use different terms for the same thing. And this table is from a very popular textbook which really helped me learn about databases. It's just about databases, like 1,000 pages long, so there's a lot of content to learn about. I didn't even get close. So really, we have different terms for the same thing. So you might call the columns attributes or fields. Rows could be also called records. The table might also be called the relation, where relational databases come from, as well as the actual relationships being modelled, and so on. So I just thought I'd show you that. I also looked at the mark scheme just to make sure we are talking about the right things. And there are some keywords it has underlined, which I think would probably are what's going to get you the mark. So we create tables, we define columns, and we also define relationships, and we also set, it talks about setting, I guess you could set this to things like the columns, data types, validation rules, and so on. This question's 3 marks, and for describers maybe a little bit misleading. Having seen the mark scheme, you only really get marks for actually stating these, so I'm not going to go too much further than that. You don't really need prior experience of data handling software, as it kind of implies, as if you should tell them in detail. So I'm just maybe write out these points a bit more. Okay, so basically just regurgitated the mark scheme, to be honest. This is the first question in this paper actually that I wouldn't be totally confident if I was in an exam situation I'd get full marks on, because it's a bit of a lottery. It seems kind of harsh. I assume the line is saying you need to use this key term in order to get the mark, and that seems harsh to me. So, you know, it's a bit of a lottery whether I would actually use these terms in the exam. I guess these are the proper terms, but you never know what you were gonna write, so it's kind of harsh. Anyway, this is the other mark you'd get it for, if you're wondering. So if we maybe move on to the next question, which is actually, so 2 key differences between these questions. This part C is asking us to state 2 tasks for hairdressers, so we're actually going back to the context, can perform using this software once the database is in use. So now we're adding rows to our database, so to speak. Whereas this is just a generic question about data handling software. It's got nothing really to do with the hairdresser. So here we need to be careful not to just slip into this theme of just talking about it in general. We're not saying specifically what the columns are going to be. Here we need to talk about the actual context. So the actual example it uses in the question of clients and their appointments, we can use that for the first one. So just what they're going to do with their software, what's a hairdresser feasibly going to do? Well, they're probably going to add new clients into the database, maybe client details. For handwriting is getting progressively worse. You also, a hairdresser may search for an appointment. Another word for search might be query. That's a word we tend to use in databases. This is just a request for data from the database. Just because I've sort of devolved into this now, I might as well show you the mark scheme again for this point. And lots of actual suggestions. You can see all of them actually relate to this context. And so this point here in italics, typical for use for data system by the hairdresser, and it's using this data they talk about. You can't just say data; it has to be a specific. Well, actually, no. The last 2 points don't have to be in context, but the rest of them do, or at least have a relevant example. So that's quite an important point. Maybe this one about reports. If you don't know what a report is, this is just a presentation of data from a database. So often data handling software will be able to produce reports, well, just presentations of the data. Is not really more complicated than that, using a example. So all of these are in context, and you just got to be careful, like I say, not to just follow the trend of a previous question about just a generic version. Question 7 says, Dipesh is thinking of buying a tablet computer to replace his old desktop computer. Describe how the CPU and RAM work together to enable the tablet computer to operate. So CPU stands for Central Processing Unit, is for hardware that actually processes the data and instructions. RAM is where the data and instructions of applications currently open are stored. It stands for Random Access Memory. I don't think I explained what random access means, so maybe I could do it now. This could be ambitious. So if this is a stick of RAM, this is the limit of my artistic skills. Depending on where the data is stored, the actual physical location of the data doesn't actually matter. So whenever it's accessed by the CPU, it doesn't matter where the data is. The actual time, the latency, which is the response time, doesn't actually matter. Whereas a hard disk, for example, isn't a random access device. So the disk that spins inside this, we have the read-write head, that actually reads the content stored. This is awful, but the actual location of the data affects how long it is. So where it's stored on the actual disk actually affects the read-write time, whereas random access memory, this isn't the case. This diagram shows how the CPU and the main memory is connected. The main memory is pretty much synonymous with RAM. And they're connected with something called a bus. I don't think you need to know about this. All 3 units that comprise this basic CPU model. But really they're connected with a bus. And okay, to do a bit more drawing, if we represent the secondary storage of this box, so this is the secondary storage, we have program data here stored in our secondary storage. This is our persistent store of data, and when you open a program, this is loaded into the RAM. The data is loaded into the RAM, and so the RAM is where the instructions and data for programs currently open are stored. So when these instructions need to be executed, we have this fetch execute cycle we talk about. And briefly to go through this, the fetch bit is basically the instructions going from the main memory into the CPU. So the instructions are loaded from the main memory into the CPU. And for control unit decodes, we have this decode stage, which we don't always write. We have this decode stage where the control unit basically works out what the instructions are going to be, and then the ALU executes them. And registers are used for kind of temporary storage as well as some other specific features, but that's not really the detail you maybe need to go into. If you've learned about it to that detail, that's really good, but I don't think you need to know it for the exam necessarily. So the instructions are fetched by the CPU from the memory. This is quite an important point. This is how they work together, as it says up here. And the third and final point for this is only 3 marks, is that the processor of a CPU executes the instructions. So just to recap, instructions are loaded into the main memory when the application is open. When it needs to be executed, the CPU fetches the instructions from the RAM and then executes them in this unit, although that's probably a bit beyond what you need to know. Part B says the tablet computer uses cache memory to describe the purpose of cache memory. So this is the CPU also has a small store of cache. It has 3 levels typically. So the whole idea is you have this memory hierarchy. So you have at the very top, a very fastest memory, you have cache. Then you have sort of RAM in between, and then you have the secondary storage at the bottom. This is in terms of speed, so the cache is the fastest, it's the fastest of access. In terms of physical location, the cache usually forms part of a processor, and so this small store of data is physically closest to the processor. So the latency, I said that earlier, the reaction time almost is the shortest, whereas you got a tiny bit of distance to get to the main memory, and then the secondary storage isn't direct. It has to go through certain other channels to get to. So secondary storage is slower, cache is fastest. So this isn't it doesn't talk specifically about CPU cache memory, it just talks about it in general, like you have browser cache memory, and the hard disk will have some too. And really the purpose is to speed up data access because it's a faster type of memory, and it stores instructions and data that's frequently accessed, because this means it's more likely to be beneficial if it's storing things that aren't going to be accessed, then the benefit isn't really felt. But if you're accessing something frequently, like Google, if you're talking about a browser cache, then it's going to load a lot faster. So to store frequently accessed data in order to speed up access, this is kind of our first mark, and this is our second mark. And this is talking about cache memory in the general sense rather than directly in context with the CPU. Part C is another 6 marker, and it's about advances in memory technology and how they've allowed significant improvement in the performance of devices such as tablet computers, and again the quality of your communication will be assessed. So similar to the first one, actually, it's not a really technical question. The answers aren't very sophisticated. I mean, really, just to do a bit of a plan again, not maybe so detailed, but the memory has got physically smaller in size. As with all technologies, it ends up costing less. This has probably also become faster, and to be fair, I don't really know I don't keep track of the memory technology improvements, but you can safely assume that it's an advance, and there's only so many things that can change with memory, the size, the cost, how fast it is, I guess how reliable, how durable it is, and it's a 6 marker, so I would say for this 3 points, so I'm going to write about these 3 points, I think. And in terms of actual performance, this is maybe quite important. It's not really asking about, like, the cost isn't beneficial to us. I mean, I don't think Apple or Samsung really pass on a reduction in cost to the user, but this maybe means, and so does a physical size, that you can other components can be better maybe. So this is my answer. Again, feel free to pause it and read it if you want to. It's nothing special. I won't be entering it for any prizes because I don't really know much about this, and the mark scheme, having looked at it now, I might as well show you again, is pretty vague. It doesn't come up with many reasons. I guess if you get a question like this, they won't repeat exactly the same question, but you could get a similar theme, maybe 3 mark or 4 marks. And these are the kind of ideas they want you to come up with: smaller in size, faster access, larger capacity, more durable, cost less. And this is a bit of a confuse me a little bit because it talks about how the technology, the actual tablet can be smaller, be more mobile, and have a similar capacity. Well, that's not really relevant to the performance of the device. So I've tried to link every point. I've made basically 3 distinct points here, hopefully to get 2 marks each, although it doesn't really work that way. Although I've always linked it back to the performance. So I'd imagine this is how you should probably do it. It's probably how the examiner wants you to do it, but the mark scheme doesn't really reflect that. So I don't really want to over talk about this too much because we talked about the standards one for a long time. But again, this is a similar answer, which you don't even need to know any specialist knowledge. I don't know any specialist knowledge about memory technology and how it's advanced. I might try and find out some if you have any specific points. It'd be interesting to hear about them. But these are just sort of slightly obvious points, and the mark scheme has reflected that too. So let's move on to the next question, which is about a microwave oven now, and it's controlled by a small specially built CPU. And the table below shows some CPU instructions and what they mean. And part A says, using examples from the instruction above, state what is meant by an opcode and an operand, and they're 2 marks each. So this is, you just got to make sure you use an example. And so firstly, just to state what it's meant by. So the opcode is the part of the instruction that actually specifies what the operation is going to be. So this is the operation add here and here, so these are the opcodes in this sort of written out instruction. And so represented in binary will be, well, usually we write the opcode before the operand, so the actual order like this. But even if you weren't sure, the fact that this is the same binary number as this suggests that because they're both add, this is going to be the opcode and the second half is going to be the operand. And actually this is about subtraction, and this is a slightly different binary pattern. So let me just write this up. So it specifies the operation to be carried out, and then just e.g. uses, this is literally using examples from these instructions. I'm just going to write out this binary pattern, and then I'm just going to say equals add. That might be unnecessary, but might be useful. Okay, so the operand is the actual data being used in the operation. So as I say, specifies the data being used, and this is the second half of, well, either. And so this is 1 in binary. This also, it isn't because the table says it isn't, but this also could represent a address, like a register address, but that's not really relevant. So it now says the time displayed of a microwave oven is represented as 2 8-bit binary numbers, so this is also known as a byte, and 1 for the minutes and 1 for the seconds, so 820 stored as, so this is 8 in binary and this is 20, which kind of gives you a clue what's going to be coming up, and this is again 15 and this is 45 in binary. And okay, if I very quickly show you how you would work that out if you weren't sure. So this is really, so hypothetically, if this was a different question, it was asking us what is the denary equivalent of this binary number, this actual one here, then what I would do, I'd construct a table, write in our headings, which go up in powers, well, it goes up, it doubles each time because it's base 2, and I'd then write in the binary number, and basically what you do, you multiply the columns by the rows, so this is basically just 16 plus 4, which is 20, as I say, although to be honest, when you get enough practice you can just spot that's 20 relatively easily. If you're uncomfortable with this and anything I'm about to show you in a sec, you might want to watch a video I did on binary because we talk about it in a lot more detail. So the pattern is that the second byte is the seconds and the left hand byte is the minutes, and so 5 minutes 30, we need to basically work out what 5 is in binary as a byte and then work out what 30 is in binary as a byte. So let's, again, I like the table method. 5 isn't particularly difficult, but 30 maybe we might as well do a table, so I'm just going to do a table for both anyway. So first of all, let's just work out what 5 is. So using my wonky table, if we just write 5 up here, this is how I tend to do it, although like I say 5 is not very difficult. Basically we make our way along and we write down how many times the column heading goes into our number. So all of these go in 0 times. So the last one to maybe think about, does 8 go into 5? No, it doesn't. So we could write a 0 here. In fact, we're going to need to write a 0 here basically because we need to express it as a byte. And you can see we have leading zeros here, so we need to also do it as leading zeros. So the first one does go in is 4, so we write a 1 down, and we now have a remainder of 1. 2 doesn't go into 1, so we write a 0. 1 goes into 1 once, and so this is our 5 as a byte in binary. So I've just written it down. If we now do it with 30, so the first thing we can do is say, well, first of all we can write our, let's do it in purple this time, we can write our leading zeros in, because immediately if we have 30 here, these ones aren't going to go into 30, 32 is the closest, but then 16 does go into 30 once, remainder 14, because 30 minus 16 is 14, 8 goes into 14 once, remainder 6, 4 goes into 6 once, remainder 2, and then we have 0 remainder at the end, which 1 can go into. So that could be how you work it out. There's other methods to work at binary. Again, you might want to watch my video or another video on binary if you're a bit confused. But I think a bit of a misconception is that you get lots of marks of binary. I think because people think it's pretty much a computer science paper or computing paper, that you're going to get a lot of marks of binary. It's one of the topics that stands out probably when you're taught it by your teacher, but really you're only really going to get a 2 marker because it is quite a fundamental skill. I think most people should be able to do this relatively comfortably, so they're not going to award you 10 marks for doing a simple conversion. It's going to be relatively simple. It's the other content that's going to get you the main marks. So really the point is we just express this with this gap in the middle. Part C is worth 1 mark, and it gives us this bit pattern, and it says that this can either represent the instruction add 20 to the timer or the data 820, and it's asking how the CPU can determine whether it represents an instruction or data. So because it's worth 1 mark, it's not a very complicated response, although it's not an easy response. Maybe if you think about it or if you really understand the process, maybe it's obvious. And I think it's been more than a year since I made the video, but I think I explained a similar specification point, slightly different to this. I think it was more, I was trying to say like the opcode or operator and the operand in terms of the order they're received is what determines what they are, but this is slightly different. This is more about 2 separate bit patterns that aren't really related. Well, no, they are kind of related, because if you think about it, if this is first of all the instruction, add 20 to the timer, and this is the time, so it's adding 20 to this. they're two separate parts of the fetch execute cycle. So first of all, the instruction is fetched from memory. That's the fetch bit of the cycle. So this is fetched, or the fetch part of the cycle. Whereas this is more the execute stage, where this is actually being added to the time. So first of all, one point, and actually this would be worth 1 mark, is to say that they're from. They both happen at different parts of the fetch execute cycle. So this would get you 1 mark just for this statement, and it's, I wouldn't say obvious because it's a tough question. If you don't understand this, it's not easy, and I find it difficult to explain. But hopefully you can see how they're related and how they happen at different stages. The CPU is going to fetch this instruction in the first stage of the cycle, then it's going to execute it, and essentially it's going to follow this instruction, and it's using this previous bit of stored data in that. The second mark, or the second possible mark, is about the example would say that instructions or data are kept in separate parts of memory by the operating system in brackets, and that's true. They are kept in separate parts. They have their own addresses. The CPU is what is actually fetching the data. The CPU, and I might as well show you it. So this is the point I just said, it's kept in separate parts of the memory. And it talks about something called a program counter. This isn't something I don't think you need to know, which is why it's kind of in this section, the guidance section, rather than the actual answer. Program counter is a register. So as I said, this is kind of a small store of data in the CPU, and the program counter increments, it updates with the next instruction to be executed. So this saying about it points to the address, well, they have their own address, and so it kind of keeps track of it that way. But this is the probably better answer to put. Question 9 begins by talking about a bank that uses a local area network, a LAN, to connect all the computers in its head office. So a local area network is just a network over a small geographical scale, so like a head office, like a school, like even a house. And so you can classify networks in a number of ways. So this is a geographical way. You also have a wide area network, which would be, well, the internet is a key example of a wide area network because it's got a much larger geographical scale than a local area network. And this question is worth 2 marks. It's saying to state 2 ways the local area network can be used to monitor the work of employees. And this is another question. I've noticed quite a lot of these so far, where it's not something you can really learn. You just have to think of it on the spot in a way. So you've got to just know, apply some knowledge of what they could do. So to monitor their employees, well, they can look at the employee screens. This is called remote access. So they can use the network to take control of their computers and see what work they're doing. They could also monitor browsing history to make sure they're not on social networks and on YouTube the whole time. And again, this isn't really a very complicated technical answer. You just have to think, think about what your school's doing perhaps to monitor the students, and it's the same kind of idea. It's not something you can really learn. You just have to think about. And there's quite a few on the mark scheme. I seem to be doing this more and more, but yeah, quite a few ideas, and it's not just the advantages of using a LAN in general, it's the actual how they can use to monitor it. Part B says computers in the network can be identified using both IP addresses and MAC addresses. Describe 2 differences between IP addresses and MAC addresses. So this is worth 4 marks, 2 marks for each difference. This is slightly more technical, so I can maybe be more of help. IP stands for Internet Protocol, and MAC stands for Media Access Control. And so a MAC address, maybe a bit of background. So all devices to connect to a network have to have something called a network interface card. It's probably built into your computer. The other name for this is network adapter. And so all network interface cards or network adapters have a identifier called a MAC address programmed into them. And so usually it's written as 6 bytes. So let me just find a MAC address to write down. So this is an example MAC address, and it's usually written hexadecimal, so hex, and it's 6 bytes long. So if you remember, each hex digit stands for or represents 4 bits, and so 8 bits is a byte, and so this is representing 6 bytes long, because we have 12 lots of this, and usually we separate them with hyphens. So each interface card has this manufactured into them, so usually stored on some read-only memory, and This is unique worldwide for MAC address. So the IP address on this LAN isn't necessarily unique. So the IP address isn't necessarily unique, whereas a MAC address is unique worldwide. So because this MAC address is actually built into the hardware, you cannot change a MAC address. So you cannot change. And there's no reason to either, really. The main use of MAC addresses isn't on the internet, because you can't route packets using a MAC address, because a MAC address offers no indication of where the device is located, because so the first half of a MAC address, this is going into a bit too much detail, this is the manufacturer code. This is actually the unique code for your actual device based on manufacturer. So this could be a Chinese manufacturer, and there's no indication that this device is actually in China, whereas an IP address actually offers some indication of where it's located. So just to emphasise, MAC addresses can't be changed, they're unique worldwide, and they can't be used to locate a device geographically. Whereas an IP address is what the router, which is a device that forwards packets, data packets, which is how the data is sent, is actually used to identify where the device is. So the IP address identifies where to send the packet. So it defines where it is geographically. They have a much more defined hierarchy. And again, maybe a little bit too much information, but there are two versions of IP addresses really in use. IP version 4, and this is 32 bits, and IP version 6, and this is 128 bits even. And they basically ran out of space. 32 bits wasn't enough to locate everything on the internet geographically, but this is only talking about a local area network because it's singular. And so an IP address can be static, which means it doesn't change, or it can be dynamic, which means it changes whenever you join a network. But the key point is, at least at this level, that you can change. So you can change. My backwards ticks. Whereas a MAC address can't. So this is one key difference we can talk about. So the two differences I'm going to talk about, there are other ones here you could use, are the fact that MAC addresses can't change, they're programmed into the hardware, whereas IP addresses, because they're controlled by software, can change. So whenever you join a network, you could get assigned a new IP address if it's dynamic. And I was going to talk about the fact that MAC addresses are only really useful within the LAN. So this is what I've written. First point is relatively standard, and the second point is about the fact that MAC addresses are only really useful within a LAN, and you can't route a message using their MAC address, whereas a MAC address might be used in order for a device to know whether it's the intended recipient, because data is sent in a packet. So say this is a way of visualizing a packet, you have some data, so the data is sent in a portion of a packet, and also bits of a packet have, like the MAC address, have the IP address. They also have things like, you might have heard of these, you don't need to know about them, but checksums, which are for checking the message gets there. Things like this are also contained in the data packet, and so they might use the MAC address just to be sure that they're the intended recipient. Part B is worth 4 marks, and talks about the bank network using failover, and this is a network policy, and it says to describe what is meant by failover and just justify the need for failover in the network. So failover is about having backup hardware. So the bank may use a piece of hardware like this. This is a router, and so this is the hardware that actually forwards the packets across the internet. This is an industrial one, it's not the one you have in your house. There's nothing like that. So they may have more than one of these. So they may have a backup one in case the first one breaks. So if this one breaks, then they can't connect to the internet because they can't forward the packets. They don't have a backup. Whereas if they use this policy called failover, they automatically switch. It automatically switches to this working one, and so this can take up the slack while this one's broken. And an example in real life might be a bridge. So a suspension bridge has loads of cables on. They're not all needed to hold the bridge up, but if one of the cables fails, or 5 of them fail in winds or something, the other cables are there to make sure the bridge doesn't fall over. This kind of concept is called redundancy, and this is repeating key components. This is what the failover policy does. So why do we need this policy? Why do we need backup hardware or secondary hardware or redundant hardware? Well, we need it to prevent loss of service in a bank, especially if customers are using it. the bank need to have all their hardware up and running, they need their network to be up and running, people's money, they'll lose customers, and so this is why it's really important. So failover is a network policy in which redundant hardware exists in the network to automatically switch to. This is actually underlined in the mark scheme, or at least switches. I originally written to take over, but that's probably too colloquial, and this is what the examiner would want you to really use, to switch. Maybe you'd get from mark if you wrote something slightly different, but you never know. And really the key bit is you use an example relating to the context of the bank. So I've just said loss of customers, which is maybe a bit extreme, but is possible. Finally, on the last and 10th question, this is shows a game on a computer with 6 players around a table on seats. They're numbered 1 to 6 as shown below. The names of the players are stored in an array with 6 elements named player name, and the index position of the array is used to indicate the seat number. So for example, the value of player name 1 is Helen. So you can see we've got the index number written under the person. So when it says state the value of player name 3, this is just going to be Lydia, because it says Lydia's index number, so it's going to write down Lydia. So I suppose the only way you might get this wrong is if you're being not too clever, but you're thinking it may be tricky, because often arrays use 0 indexing, where you start counting from 0, and often this is the case, especially in programming, but in this case they're not, because they're starting from 1. So if it was 0 indexing, it might say in a question, or it might be just be implied. Helen would be 0, Adam would be 1, Lydia would be 2, and so on, but this isn't the case. Part B says, describe what will happen if the code for the game includes an instruction to print the value of player name 7. If we scroll up, we can see we haven't got a player in position 7, so there's no element. There's only 6 elements in the array. There's no element in position 7 of the array. So when this code is executed, it will find that there's no element in that position, and so we'll get an error message. An error will occur. And this will be our 1 and second mark here. So the last part of this paper is quite a tricky one, and it's worth 6 marks. And this is asking us to write an algorithm that will update the contents of this array after a move has occurred. And so the idea is that during the game, each player sometimes moves clockwise by a given number of places. We have to input this number, and we have to use iterations, so loops. And the way I'm going to do it, I've spent about 10 minutes on this so far, just without recording it. Maybe 5 at the max. We're trying to work out how to do it. It took me longer than I expected, because it's not easy. We have to, this point about ensuring that all the existing player names are moved to the correct position is quite difficult, and I wasn't initially sure what the loop was for. And I spent about maybe another 5 minutes trying to work out how you can do it differently, because I looked at the mark scheme and mine is annoyingly similar to how the mark scheme does it, and I was hoping I'd be able to show you a couple of different methods, but I've really struggled to think of any other way of doing it. So if you came up with a better idea or a different way of doing it, let me know, because it'd be maybe useful to show a couple of solutions, but it's a bit late now. So we have to first do an input line, and so it's an algorithm, and there's a couple of ways you can express algorithms. I think this is just going to be pseudocode, and pseudocode is just an informal description of an algorithm. I think a flowchart would be inappropriate, and you probably wouldn't get marks for a flowchart, or it depends. It's better to use pseudocode in this example, or even program code, but pseudocode is probably better. So first of all, we just need to input for a number of places to be moved clockwise. So in this example, the number of places being moved is 2, so Helen goes from here to here in position 3. And yes, let's just do an input line. So I tend to do in pseudocode my input and words like this as capitals to distinguish from identifier. So what can we call it? Let's call it move by, because I'm moving by 2 seats, 3 seats, whatever. It's not a very good variable name, but anyway. So we then need to do a loop, and so what I'm doing in this, and I'm kind of copying off my handwritten things. We're going to have to. What I'm going to do, I'm going to loop. So in my loop, I'm going to use a for loop effectively, and we're going to do an indefinite loop, which means you don't loop a set number of times. You loop based on this variable, and in fact, I'm going to write my loop as. First of all, we're going to set Chan as Priya. So Priya is now going to be in position 6, because what I'm going to do for each loop, I'm going to move one along. So I'm going to move one along each time, and then we can repeat that. The thing I found difficult was, I mean, not difficult because you just have to think about it, but when you're overwriting them. So when we're moving Priya to position 6, because we're moving one along, we basically overwrite Chan and we get rid of it, and we need to save that. So you need to either use another temporary array, but I didn't really fancy writing that out, so I'm just going to use a variable named temp, and I'm going to use equals for this. Some pseudocode uses like a little arrow for variables, but I'm not going to use that. So temp is now going to be, we're going to use the person in position 6, because we're going to overwrite this. Then we can replace the person in player name 6 with person in player name 5, which is initially going to be Chan being swapped for Priya, but we have Chan saved, so we're not losing him. So if we're going through this code for the first time from these initial positions, we now have person in position 5, which is Priya, now also in position 6, because Chan has been overwritten, although we have him stored here. So we need to now do the same with Kwaku in position 4, and basically overwrite Priya in position 5. So if we just, I'll fill it in a second, but if we just write position 5 there now with position 4, and now it's the same process. So we need to replace Kwaku with Lydia, who's in position 3. Now with Adam in position 2 to position 3. So the final normal-ish one is just to finish this off, kind of, just to do the last normal line, because we are now replacing Adam, who's now been moved over here to position 3. We're now overwriting it with Helen, who's currently in position 1, so that's fine, that's pretty normal. But we now have this gap here, so Chan has been stored in this temporary variable because he would get lost otherwise. He gets overwritten straight away, and so we now can replace Helen in position 1 by Chan, who was in position 6. So I've just added this line here to wrap the loop up, I suppose. I tend to write this closing line when I do pseudocode with loops, although not all languages actually would use this as part of their syntax, although of course pseudocode is language that's never going to be executed, so it doesn't matter so much as long as you're consistent. A lot of people, I think, get a bit paranoid about pseudocode. They think they need to write to a convention. There's an OCR convention or whatever. There's not. You don't need to worry about that as long as your code looks like code to an extent and is clear to the examiner what's going on. So I've just changed the colour, obviously, to make it look a bit nicer, hopefully, and also just added an indent. Not necessary, of course. In most languages, this white space doesn't mean anything, so people add indents just to make it look a bit more readable, I suppose, although it doesn't matter so much. Hopefully by now you understand what's going on here. So really we're just rotating this table or this shape, but really we're doing this just with an array, and so we're just basically overwriting each element along as we move across the array, and then we need to be a bit careful when we go back to position 1 because we're using this player name that's been overwritten, and so we need to store it to make sure we keep it safe. So for most people this would be the hardest question they're going to get, because you're given this scenario, you have to write some code for it, you're put on the spot, you're not going in with loads of information to write about, you have to do it in the exam hall when you're doing your exam. And that doesn't mean you can't prepare for it though, because the best way to prepare for this type of question is to do as many of these types of questions as possible. So there'll be one in every single OCR paper, I'd imagine, and do all of them, look at the mark scheme. If you don't think your answer's matching up to the mark scheme, feel free to take a picture of it, send it to me, email it to me. My email address will be in the description, and I can take a look. And do as many of these as possible. If you don't get one, come back to it later, see if you can work out what's going on. If you just get confused, try it again, keep trying, and the more you do it, the more practice you'll get, the more prepared you're going to feel when you go in to do this question. And if you just don't think you can do anything, just try and write some code. You're going to get a mark for this input line, the easiest bit of pseudocode, just because it's in this bullet point here. So that might help you. You might even want to do some questions from other exam boards. So other exam boards at GCSE like AQA and Edexcel have questions like this, very similar, and they might share ideas, you never know, so it might be worth doing other ones too. In terms of some general advice, not just for this course but for your GCSEs in general, I know you might have done half of them by now, make sure you use the specification. So for this course especially, the specification is really important because it tells you what the exam board want you to know. And a tactic, if you want to call it that, I used to do is print off the specification and then I'd annotate it. So the specification, in fact, let me show you one. So I dug out a one I did for economics, I believe. Obviously not a very good one, because I would usually cover the specification in notes, usually the night before the exam, a couple of days before the exam maybe if I had time, and then I'd take it with me on the way to the exam. I only have my pencil case, water and this specification with loads of notes on, and then I'll just bin it straight before the exam. I'll just bin it before I went into the exam hall. And those notes, first of all, when you're making the notes, you can pick up bits. So there are certain keywords on the specification, bits you might have forgotten about, bits that are hidden, bits that your revision guide, your textbook doesn't really talk about, and it makes sure you're not going to get caught out in the exam, and helps refresh things too, because you're literally covering the whole course in like an hour or however long it takes. This exact one I haven't exactly covered because for a reason I still have it. The rest I've just binned, as I say, because this one I probably didn't bother taking, so I didn't do too much for, but you can kind of see what I'm talking about. Another bit of advice that's quite generic is to just do as many past papers as possible. For this course there's loads of papers available for you, a lot more than other computer science courses, and it means basically everything that could come up has probably come up in most papers, so really important you go through those and do as much practice as possible, even if it's just a glance, and then look at the mark scheme, mark it yourself, see what the exam board writes in the mark scheme. And they also publish examiner reports, usually for most subjects, and those can be quite useful. It's the examiner telling you where the majority of people went wrong. If they offer any advice, that can be quite useful. A third point, which may be really obvious, hopefully it's really obvious, and that's to actually revise during the exam period. As far as I can remember, I don't think this was the case for everyone. I remember friends of mine just seemingly not giving up, but just deciding that it was too late, even the night before. But if they were going to fail it, then it's too late to change it. Well, really that's not true, especially with GCSEs. Not so much maybe when you get a bit older and do harder exams, but during GCSEs, the exam itself is often not that hard, or the content itself, it's more the endurance of it. And I think that's true with the GCSE exam period in general, because you're doing lots of exams in a short space of time, and it's more keeping on track of it yourself. The actual content can be sort of picked up relatively quickly. A lot of my GCSEs came from revision the night before, essentially. That's not something to be particularly proud of, but it's reality. So last minute revision really does work, at least it did for me. Make sure, the obvious, don't stay up too late. I also realised very quickly for me that I needed a certain amount of sleep a night. I've had some exams go really badly in my time, and the one thing in common with all of them is I just didn't get enough sleep the night before. So revise the evening before to an extent. Now this may be too late really, because you haven't got a ton of time, especially if you're watching this during the exam season. If you are wanting to make notes, if you think they're going to help you, it's better to write them out in your own words. I get a lot of people asking me to send them the PowerPoints or send them notes for my videos, and I don't think it's totally helpful, because using someone else's notes, I've tried to do it in the past without much success. It's better just to, instead of copying, write them out in your own words, although this may, don't spend hours and hours during the exam period writing notes in nice colours, nice spider diagrams, because it might be a waste of time. I think it's really important to have a plan of action before you sit an exam. You want to be knowing how long you're going to take to do each thing roughly. So often people say a minute a mark, so you spend 8 minutes per mark, and in computing it's an 80 mark paper and you have an hour and a half, so 90 minutes, so you have 10 minutes spare. But in this specific instance, I would probably try and give yourself more time on the 6 mark questions, especially because you might need to do a bit of a plan. A quick plan might be quite good. Depending on how confident you are with the last algorithm question, you might want to give yourself more time for that too. So there are certain questions, so like especially at the beginning of this actual paper, there are like 3-mark questions, 4-mark questions, which really didn't take that long. So you can kind of save yourself some time to use up later. That might be a good idea. I'd be maybe tempted if I was doing this actual, if I was sitting this actual qualification, I'd be tempted to maybe look at the algorithm question first. The very first question, it might be the last question in the paper. I'd look at it first, maybe read it through, jot down some ideas, just to give yourself a bit of help for later when you're maybe a bit more tired, you'll be a bit fed up by that point, and you want to try and do as well as possible. I also wouldn't be too worried about dropping marks, because as I showed you at the start, the grade boundaries can be quite high, so it can be like 70 out of 80 for an A-star, but don't worry about dropping marks. If there's a question you don't know, just try your best. And I guess that comes into my last point. If something comes up which seems like something you haven't learned, you haven't revised, you've forgotten about maybe, or just you didn't realise, or it just seems like it's not on the course maybe, the chances are it's an application question. There's quite a few questions actually on this paper which I've never seen before. I didn't include in my videos, but they're not very difficult. They might seem difficult if you panicked maybe, but actually you just need to apply a bit of knowledge, and it's not going to be a very difficult question if it's not on the course. So I hope this video was useful. If you have any problems, feel free to email me. As I say, it's in the description and I can try and help out. But other than that, I hope everything goes really well, and good luck.